Good morning, everybody, and welcome to Lab Innovations. Welcome to the theatre down the court in here. Talking a little bit about cannabis today. So my name's David Price. I work for Perkin Elmer as an application specialist. It's something which is really coming along pretty quick. Is that show of hands? Anybody here actually doing cannabis testing right now? Fantastic. Okay, good. So it's starting. Do you feel like it's starting to pick up pace? It's an exciting thing. Okay, great. Okay, so my talk, what I want to do is just talk a little bit about some of the definitions and the legal status, testing and why it's needed, and then talk a little bit more about what we at Perkin Elmer are doing with regards to providing solutions in the labs. So just some definitions here. So cannabis sativa is the plant, and what we talk about it being there is we break it down into being hemp and cannabis. Hemp is the low concentration of the tetrahydrocannabinol, THC, which many of you will have heard of. And cannabis doesn't have a THC threshold, but it is termed psychoactive. On CBD, you'll see this one as well. This is cannabidiol, non-psychoactive, and it's medically therapeutic. And in a similar way, we have THCA, which is tetrahydrocannabinolic acid. And again, it's non-psychoactive and it's medically therapeutic. So with cannabis, I think there's lots of nice stories about it. So I'm going to go through a little bit of a story to give you a little bit of a step back in time. No talk about cannabis is about a few little puns, so I'm going to put the one there about caveman discovering weed, discovering fire, and Stone Age begins. But it really does go back quite a way. So there's evidence of cultivation and use back 3,000 years ago. It's mentioned in ancient Indian texts from 1,000 years ago. And it did a little bit of a movement from that area, and it went across to Assyria, Africa, Europe, and then into the Americas. Rather bizarrely, when the English settlers in Virginia in the 17th century, they were actually required by law to grow hemp. Slightly bizarre one there, that you could actually go to jail if you didn't grow the stuff. A little bit of a weird one. And in the 19th century Europe, it was widely used by artists and writers. So there's a lovely bit of artwork here about enjoying the hashish. It's an interesting story, actually. There was a medic in France at that time. He ran his own little study. He was looking at people being affected by the plague. And what he found was that if he gave them a nice edible piece of cannabis together with a coffee every morning, he found that 7 out of 11 people were cured of the plague. I'm not sure that was a peer-reviewed bit of literature or anything, but it's a nice little story. So what changed? Well, got slightly more illegal, having been used for millennia. And it's quite interesting what's going on right now, because some people are saying it's a bit like being reunited with an old friend. But why did it change? I think you can probably look at maybe a little bit of this nation's history and a few other sort of European nations and blame colonization and slavery. The Portuguese in Brazil banned it first to control slaves, and the British gave it a go in India. Didn't do a great job of it, but they tried to control the use there as well. Really big move in the 20th century was Nixon. Nixon really did wage a war on drugs, and he came down very hard. An interesting political character. So more changes. As we get a little bit more recently, we've got our friends just across the water there, the Dutch. Certainly relaxed attitudes there towards many drugs and cannabis in particular. And one thing I found quite interesting was about what's happened in Portugal. They decriminalised the use and possession of all drugs in 2001. And there's an interesting graph here, this bar chart showing Portugal there at the bottom. So that's the number of deaths per million population. And you see Portugal have got 4. So I did my little bit of checking. The population of Portugal is 10 million. So that's 40 people that unfortunately, very sadly, died because of drug-induced death, which is too many. There's no doubt about that. But it's quite interesting how they rate compared to other nations due to their approach to drug use. So more changes on cannabis. Uruguay legalized it in 2013. And then some nations now have it legal and some for medical use. So over in North America, there's an awful lot of states where it's available recreationally, that's totally legal, as well as medical, and others where it's just legal for medical. The whole of Canada has legalized it, and it's used for a variety of different medical conditions. In the UK, there was the case of Billy Caldwell. I don't know if many of you know this story. Very sad in many ways. 10-year-old kid who was having probably about 100 seizures, epileptic seizures a day. A very famous case because it led to legalization in the UK for medical cannabis. In that, by taking the oil, cannabis oil, it was actually down, I think it was about 300 days without a single seizure. So go from 100 seizures a day, I can't really imagine how you can live with that or how the parents live with that, but down to none over 300 days. There's also a lot of work going on within the pharmaceutical industry as well. GW Pharma have an FDA-approved plant-derived CBD drug, which is out now as well. So some really good work going on. Okay. It's all about testing and why it's needed. Well, I think, why do we test it? I think it's pretty obvious. If it's illegal, there's no testing, and there's absolutely no idea about what you're going to be taking in. So it's massive risk, and when we talk about those drug-induced deaths, maybe that's where these are coming from. If we do have it legalized, obviously, we then have the need to make sure we're going through the process of making sure it's safe to ingest, smoke, whatever it may be. So let's go back a step and just think about modern day uses. So when we talk about the low THC content hemp, at less than 3.3%, it's used for a variety of different things. I don't know how many of those you can see, but yeah, there's the old style fiber, oil, food feed, and CBD itself. When it comes to using it for pharmacological production, we're actually taking advantage of some of that more psychoactive and powerful THC, but a variety of different areas. And we also have those recreational ones as well. So again, I don't know if you can see that, but yeah, Trips Ahoy, fantastic bit of marketing there, isn't it? I mean, I'm not being paid by them or anything, but yeah, Trips Ahoy, oh my God, that's good. Plenty of gummies, and yeah, these are all labelled with how much active substance they contain. Sorry, no Trips Ahoy free samples today. I have to put that on record. So what about the importance of testing? Well, there's a fair few numbers up here, but this is certificates of analysis as of May of this year, and looking at a variety of different tests in a variety of different substances. And this is actually looking at about 50,000 different test batches. And really quite concerningly, almost 10% of them are actually failing. So it's kind of proving that there's a lot of work still to be done. And I found it really interesting when you look and analyse this a little bit further, that this is happening across all categories, so it's not just the gummy bears or your Trips Ahoy cookies or anything like that, it's across everything. And almost half of it is due to inaccurate labelling. So this tells me that the people that are producing it are either not testing it appropriately, or they're being a little bit naughty about what they're saying on the label. 26% of those fails are due to pesticides. I don't think any of us really want to ingest too much in the way of pesticides. And 6% of those fails are due to heavy metals as well. So there's quite a lot of concern going on. So what are our lab challenges? I work in a lab, I think a lot of you work in labs. We get challenges in the lab, don't we? And there's plenty to go on with the cannabis testing. It's a limited methodology. The lack of standardization is a huge problem. People are doing their own things, and this can be down to different national criteria or state legislature or whatever it may be. There's a lot of variability out there. There's so many different methods that you can take, so it's very difficult to actually work out how you can actually take this on. And there's a huge variation in that sample preparation. Some of that's down to human error, and some of it down to actually how much of the sample you actually take through that process. It's interesting, in communication with a colleague of mine over in the States who works on the West Coast, where she's covering kind of Oregon and Washington State, and she says she goes into labs, a lot of different cannabis testing labs, and the quality of the people they've got working in the lab is not great. They've set up labs from maybe an old back of the garage kind of setup, and it's really quite concerning about some of that lack of knowledge. So I'm very much on that kind of, come on, let's see what we can do and improve the quality of lab testing. The last thing there is on diverse matrices as well. Obviously a gummy bear isn't the same as a cookie. It's not the same as the actual flower itself. And there's no one size fits all when it comes to these guidelines. So cannabis, I think you probably know, has some pretty complex chemistry. The things that we tend to get excited about are those cannabinoids. And also just to say where they come from these trichomes. So this is on the flower. I'm not trying to give advice about what to smoke or anything like that, but it's all around the flower, and it's on those little hairs that are on the end of the flowers as well. So, what are Perkin Elmer doing? What can we offer with regards to a solution? Well, that's what I'd like to tell you about. We've obviously got a lot of work into this. So, if we kind of just break it down onto the different areas that we need to test, that is really busy, an awful lot of molecules up there. A few elements up there as well, but really it's just breaking down the different things we need to look at. So we're looking at those interesting substances, the cannabinoids. We're also looking at terpenes, which are naturally occurring. We're looking at residual solvents, which are part of the problem when we try and refine and make the material ready to ingest. We're looking at the toxic elements as well, so things like arsenic and mercury. We've got mycotoxins as well, which are derived from fungi, and we've obviously got those pesticides, which seem to be failing so much as well, a whole swathe of different pesticides. So all we've got is different techniques about how we can deal with that, and I'd like to go through these one by one and just give you some very brief examples of how we can do this. So if we start off with HPLC and looking at potency. So this is often looking at the amount of THC and other cannabinoids in your samples. Got a very nice simple approach to it. It's using our Flexar HPLC with a photodiode array detector, and we can look at 16 cannabinoids. The samples that are extracted, dependent on what they like to be extracted in, may be extracted into methanol, could be into dimethyl sulfoxide. And what we have then is we use a C18 reverse phase column, and we've got analysis time of just 6 minutes. So it's a really nice, simple approach to it. Also on potency testing, I just want to mention also the fact that you can use near-infrared as well. And this is a really nice and quick process of actually sort of looking at that ratio between THC and CBD. And this is appealing to a lot of people because it's lower cost. Lower cost for setting up an LC and all the reagents involved, and you can quickly get this information out. In fact, it's a 90-second test. So it's a nice approach. Okay, so moving on to LC-MS-MS. This is triple quad LC. And I just want to tell you a little bit about the QSight LC triple that we have. It's a really nice bit of kit. And one thing I really want to just pick out on is this laminar flow iron guide. So there's a lot of LC triple quads out there. This one is one which uses a background gas to ensure that ions are transferred through into the rest of the ion optics without there being any need for any kind of axial field on the system. That means that there's less drift, there's less analytical drift as the internal surfaces get dirty, and we can actually then ensure that we're getting all material down there, less analytical drift, but also less downtime from a maintenance perspective as well. So it's a really nice innovation, and we've got a really nice solution for the cannabis testing with this. So when it comes to different limits, I kind of mentioned earlier about these, the fact that everybody has different limits, and here we have got some. This is comparing two adjoining states of Oregon and California and their action limits. You can see the Californians have been maybe a little bit laid back, and they say, oh yeah, everything at 0.1 ppm, and Oregon have obviously looked a little bit more at the toxicity, and they've come out with some different limits. When it comes to the QSight, I just want to give some reassurance that we're able to meet these kind of limits. These are the QSight limit of quantification values in ppm. I don't think any of those are going to cause any problems, so it's a really nice bit of kit for doing the job. The other thing the QSight can be used for is the mycotoxins, and these are these secondary metabolites that come from fungi. It's in a lot of different foods, food material. It's a big concern to us because most of them are carcinogenic. And in fact, there's a chance of actually acute poisoning on these as well, and that can lead to the vomiting, the diarrhea, and all those lovely things, and even acute liver disease that you could get as well. So I just want to give another example of where we can achieve what we need to achieve there. So this is just looking at the category 2 mycotoxins, and our limit of quantification there is looking good as well. So moving on to GCMS, using Headspace, this is where we can look at these naturally occurring terpenes and also the residual solvents that could end up going in there. So as I said, they're naturally occurring. They're produced by a variety of plants, and even some insects as well produce these materials. And residual solvents are those impurities left over after an extraction process. So very simply, just showing how quick we can do it. This is an 8-minute runtime using the system, looking at 38 different terpenes. And then looking at the residual solvents as well, using a bit of the mass spec to tell one from the other. And here we're looking at these kind of things like acetone and benzene and the kind of things that we don't want to have in there. So the final box is to talk about the ICP-MS and looking at the heavy metals. And the interest here is really just on 4 elements. I mean, we've got a choice of about 70, but it's 4 that are most concerning. They're the most toxic. So that's the cadmium, lead, the arsenic, and the mercury. Now this table, again, I don't know how much of that you can see, but it just shows how much they are varying depending on where they're being set up with the limits. Some are based on ingestion only, some are based on the body weight, some are just wholeheartedly how much is in that gummy bear or that cookie or whatever it may be. So massive challenges. It's not just the plant material. Mountain high suckers, great in that. You know, there's the gummies again. And even in the vapes as well. And yeah, I just want to spike out the vape pen, actually. So there's a lead contamination story that came out earlier in the year about this. It's reported in the Baltimore Sun, where they found lead in cannabis containing or THC containing vape pens. And the results indicated that lead wasn't coming from the vape material itself. It was actually coming from the heating coils. And I don't know if any of you have come across this before, but it's of real concern with some of those lower cost vape pens. I mean, I don't use them myself, they look pretty cool, but yeah, I don't use them. But it's something to maybe bear in mind, so I just want to spike that one out. So what do we do for meta-analysis? We need to digest the samples one way or another. So we're going to use microwave digestion. What we tend to do, because the organic content's pretty high, is we're going to treat with some hydrogen peroxide first of all. We're then going to add in some concentrated nitric acid, and then we're going to bake them up in the Titan NPS microwave. So this is under pressure, it's high temperature, we're getting that total dissolution. And the good news is that even though the samples can all look really, really different, they all turn out being these nice clear solutions. So whether it be the flour, whether it be some of those Trips Ahoy cookies, or whether it be actually an oil that we're doing the digest, it all comes out looking the same. So analytically, what we do is we then use the Nexium ICP-MS. What we're doing there is we're taking a liquid sample, those nice digests, into a argon plasma. It desolvates and it provides ions, those positively charged ions that we take through the mass spectrometer. We turn a lovely right angle degree there with our quadruple ion deflector, and we turn our ions into the mass spec, where we're looking at sub-ppc levels, great sensitivity on this technique. So on the Nexium and also the other methods, what we have is a standard operating procedure. We're making it as simple as we can for people. And on this one also, because we're having to do it in a way where we've got some data integrity, we're using a way where we can use an automated method validation tool. This is inbuilt within the software, so we can have some new material coming in, we can run those tests, and then we can get that validation report out. So some of you in the audience may be used to sort of 11-day tests, NS30 style tests. In the case of this, what's needed is actually a 2-day test. It's a very thorough test, but just a 2-day test. And this software actually allows you to provide a report at the end of it to say, yes, it's okay, and that's validated, ready to go. So that's the different techniques. Very much a quick race through, obviously tight on time, but just wanted to sort of mention those different ones, and also just to flag up that there are SOPs for all of these methods. This is something that Perkin Elmer have put a lot of time and effort into making it as easy as possible for you to use. So it's tried and tested. I don't know, has anybody heard of Emerald Scientific? I don't know if this is something you guys have come across. It's a proficiency testing scheme for cannabis and cannabis-related products. And what they do is they have the tests, and if you're within a certain zone, the acceptable zone, then you earn yourself a badge, which is very nice. It's like little kids being rewarded by a badge at school, isn't it? And we were rewarded some badges. So Perkin Elmer, we met these standards, very pleased about that, and very proud to show our badges. This is great, isn't it? I can't believe, I do have a kid in primary school, so yeah, let's see badges. But yeah, so we had labs both in the States and in Canada doing these tests to ensure that they comply. Okay, so my summary. So I've given an overview of the cannabis story. Hopefully it's of interest. I've explained a little bit about why we need to test cannabis and hemp, and I've presented the Perkin Elmer solution. So got some acknowledgements, but it's very much over to you if you've got any questions. Thank you. Any questions? Yes?
Have you done any application work here in the UK?
Application work in the UK, it's a little bit tricky for us. The question was, have we done any application work in the UK? It's a little bit tricky for us to do work in the UK. So I've been over to the US and I've worked with colleagues there, but no, obviously, we don't have that license to do the testing here. Yeah. Any other questions?
The heavy metals come from?
Where do they come from? So, good question. Yeah, so basically they're mostly coming from soil. So depending on where the plants are actually grown is about how much of those metals they take up. So if you are talking about working on a brownfield site or something like that and you're growing the plants, you're going to start taking up some of those metals. Yeah, it's the majority. It could be from processing as well, but yeah, that's the majority there. Okay, thank you. Okay, thank you very much. Cheers.